This was a super blizzard that lasted a billion years, counting backward from today, back to a time before even the dinosaurs appeared. This snowstorm never stopped. That was what Earth looked like during the Proterozoic. The entire planet was buried in ice and snow for a billion years. Even the equator turned into a vast, white frozen plain. 2.5 billion years ago, Earth had just emerged from the chaotic state of the Archean. Back then, Earth looked nothing like it does today. The sky glowed in shades of red and orange, filled with greenhouse gases like carbon dioxide and methane. The oceans were like a lukewarm soup, inhabited by only the simplest single-celled organisms. It was during this time that cyanobacteria, blue-green algae, began to appear in shallow seas. They looked unremarkable, but they could perform photosynthesis. At first, all the oxygen they produced was absorbed by iron ions in the ocean, forming layer after layer of red-banded iron formations. But as cyanobacteria multiplied, the iron supply was no longer enough. Oxygen began leaking into the atmosphere. By 2.4 billion years ago, atmospheric oxygen levels rose from almost nothing to about 1%. Geologists call this the Great Oxidation Event. But more oxygen also meant new problems. Methane is a much more powerful greenhouse gas than carbon dioxide. But when methane meets oxygen, it reacts, forming carbon dioxide and water. At the same time, cyanobacteria were relentlessly consuming carbon dioxide. Greenhouse gases in the atmosphere dwindled, and Earth's temperature plunged. The poles were the first to freeze. Ice sheets at the poles spread like wild weeds, advancing several kilometers toward the equator every year. Ice reflected sunlight back into space, reducing the heat Earth could absorb. Temperatures dropped further. A vicious cycle had begun. Around 2.3 billion years ago, glaciers from the north and south finally met at the equator. Earth was now a fully frozen planet. The once blue water world had turned white. Only around active volcanoes could you see patches of dark, exposed rock. Thus began the billion-year super blizzard. Global temperatures averaged minus 30 degrees Celsius. Even equatorial regions were about minus 10 degrees Celsius. The ocean surface was sealed under thick layers of solid ice. But beneath the ice, there was still liquid water. Deep ocean pressure kept water from freezing. It formed a hidden underground ocean, sealed from the outside world. So life didn't go extinct. A few kilometers beneath the ice, on the ocean floor, there were still many hydrothermal vents, spewing scalding magma and minerals. These became warm, hot spring zones. There was no sunlight here, but temperatures reached 300 degrees Celsius, with pressures hundreds of times higher than on land. Yet microbes managed to survive here. They needed no oxygen. They extracted energy from the chemicals around the vents, like tiny flames burning in the dark. They preserved the spark of life. Over time, they evolved in these extreme conditions, developing more complex survival strategies. Some even learned to use oxygen, laying the foundation for future life explosions. Throughout this billion-year freeze, life never stopped. It was patiently waiting for a chance to bloom. That chance came 1 billion years ago. A small asteroid, about 100 kilometers wide, now known as the Pangu asteroid, slammed into Earth at 64,000 kilometers per hour. The impact was equivalent to a billion hydrogen bombs going off at once. It left a crater over 1,000 kilometers wide. Molten magma surged up from the mantle, slicing through the ice like a hot blade. The several kilometer thick ice melted rapidly under the intense heat. Huge amounts of carbon dioxide and methane, once trapped in the ice and rock, were suddenly released. The greenhouse effect returned. Earth's temperature began to rise sharply. The melting ice turned into vast rivers, scouring bare rock surfaces and washing minerals into the oceans. These became nutrients for cyanobacteria and other organisms. In this warm, wet world, life began to evolve rapidly. Multicellular life emerged. Simple algae and animals multiplied in the seas. The Rodinia supercontinent gradually took shape. Mountains rose, rivers surged. Earth had finally escaped its frozen prison and stepped into a new era of development.